Hello, you are most welcome. I'm Teacher Ivan from Wuuna Educational Services. I welcome you to our third lesson. We are still looking at measurements in physics. In our previous video, we looked at the fundamental quantities. We can now look at the derived quantities. Derived quantities are simply the physical quantities that can be expressed in terms of other physical quantities, majorly the three major fundamental quantities of length, time, and mass. Examples of derived quantities include pressure, density, area, volume, acceleration, force, weight, among others. Those quantities that are derived from others, those are what we call derived quantities, or they are obtained from other physical quantities, majorly the three major fundamental quantities. Because if you look at density, density comes from volume and mass. Mass is already fundamental. Volume is also derived from length, which is also fundamental. When you look at pressure, pressure is force over area. Area is derived from length. Force is derived from mass, and acceleration due to gravity. Acceleration is also derived from distance and time. So that's why the best definition of derived quantities is that these are physical quantities that are derived or obtained or expressed in terms of the three major quantities or the three major fundamental quantities of mass, time, and length. Then we shall look at some of the major derived quantities in details. We shall start with area. Area is defined as the measure of the surface, and it is measured in meters squared as the SI unit of area. However, we have other units of area such as kilometer squared, centimeter squared, millimeter squared, decameter squared, acres squared, and so many others. Then, however, on area, we have different types of area we should look at. We have what we call cross-sectional area and surface area. Cross-sectional area is majorly got from what we call the 3D shapes. The 2D shapes or two-dimensional shapes. When I talk about two-dimensional shapes, I mean the likes of the square, rectangle, triangle, and others. Those are two-dimensional shapes. And from there, it's when we calculate the cross-sectional area. Then surface area is majorly obtained from the three-dimensional shapes. The likes of a trapezoid, we have a tube, a cuboid. Those are three-dimensional figures, and it's where we get surface area from. So those are the two kinds of area: cross-sectional area obtained from the two-dimensional figures, and then the surface area obtained from the three-dimensional figures. We also look at the conversion of units of area. Area has no specific instruments to use for measuring. Otherwise, since it is a derived quantity, we just simply get area using particular formula. But if we are to get area of an object, let's say a regular object, we simply get its dimensions using a suitable instrument and then apply a formula to get the area of that regular object. Then, what if it is irregular object? For instance, the area of a leaf. That one is obtained by placing our leaf on a square paper, and then we determine how many full squares and how many half squares. For full squares, we count them, and for half squares, we count the total of the half squares and divide by 2, and then add on those full squares to get the area of the irregular shape like a leaf. That's how area is obtained, and that's all what we can discuss about area. The other one is volume. Volume is simply the space occupied by any object. The amount of space occupied by any object is what we call volume. Volume is measured in meters cubed as the SI unit. However, the other units of volume include kilometer cubed, hectometer cubed, decimeter cubed, decameter cubed, centimeter cubed, millimeter cubed, and so on and so forth. Still, for volume, we can use some special instruments to measure. We can use a burette, we can use a pipette, we can use a calibrated beaker, calibrated conical flask, can use a calibrated test tube to get volume. So for volume can be measured using an instrument, just as we've seen. Then how do we convert units of volume? We can convert units of volume from one to another, as we shall see when we visit our sister page, that is Wuuna e-learning platform. You go to O-level physics, you search under the topic of measurements. There's where we talk about measurement in volume. So you will see how we convert units of volume under that lesson. So please, we have various channels. We have Wuuna e-learning platform, we have Teacher Ivan's online class, we have Wuuna Kids platform, and the Wuuna Math channel. These platforms are all in place to make learning more easier and convenient. And someone may wonder, why all these channels? These channels have different content expressed in different ways. For this particular channel, you will see me explaining certain things. Then on Wuuna e-learning platform, you will see the different setting of the videos. Then and actually Wuuna Math channel, Wuuna e-learning platform is majorly for O-level work in sciences particularly. Then for Math channel is specifically for math content. Then the Teacher Ivan's online class is specifically for A-level work. That's why we have a variety of channels. So you subscribe to a particular channel depending on which kind of level you are and which kind of content. On Wuuna e-learning platform, you will not see me physically teaching, but you will see my board and maybe plus the explanation. The same applies to Teacher Ivan's online class and Math channel. Then we also have the Kids platform where we post kids content only, both educational and entertaining. So please, let's subscribe to all these channels and make learning convenient and enjoyable. Otherwise, let us continue. We've seen volume. Then we can also discuss something about density. However, we shall look at density in details. But maybe to start with is the definition of density. Density is defined as the mass per unit volume of a substance. And since it is mass per unit volume, therefore, its SI unit is kilograms per meter cubed. Or we can also use other units such as grams per cubic centimeter or grams per cc. Those are other units of density. Then density of a substance depends on its mass and the volume it occupies. Otherwise, that has been for today. Please don't forget to subscribe to all our YouTube channels. Just go to the home button, scroll down, you'll find those channels, subscribe to them, like the content, share the content, comment, such that we know how we are serving you, where to improve. You can even ask for particular topics, we shall make them. So please don't hesitate to join Wuuna Educational Services, your trusted learning pattern. We move together through your academic journey. I'm Teacher Ivan from Wuuna Educational Services. I hope to see you very soon. Bye bye. Don't forget to subscribe. Thank you.